Hi everyone, so let us go through the implementation for the Sudoku solver as we have just discussed. So what I have in this boilerplate is I have the input ready. This is the matrix that I want to fill, and I want to replace all zeros with valid numbers, and this is the boolean function that I have created. If it would have been count the number of ways in which you can fill the Sudoku, I could have made the return type as int, but for now we are looking for only one solution. This bool will work fine, and we will stop backtracking once we found out the right solution. Okay, what we just discussed is uh, what we will do. We will try to move forward in the grid, and at some point we realize that okay, we are not able to place a right number. So in that case we say okay, we return false. That false propagates back, and maybe we filled a number here, we try to update that number, but it still doesn't work, so that again returns false. And at this point maybe we had placed 5, then we try to update it as 6 or 7 or 8. Maybe 8 is a valid number that we can place here. So what we do, we place 8 here, and we again make a forward call. Okay, we say okay, go and solve the rest of the puzzle. Okay, so this is how we are going to proceed. So just one correction, instead of going this in a zigzag manner, we are going in this particular manner. Okay, we are going like this, like this, like this. At this point, if problem happens, then we again backtrack in the similar direction. Okay, like this. So let's see how we can actually implement this problem. So let's go through the code. So first of all, I need to write some base case, some recursive case. So this is what I do for every problem. So let us think of the base case. So maybe I can say if I equals n, which is 9 in this case, we have a 9 cross 9 grid. And what we can do, we can say okay, we found out the solution. We can print the solution at this particular point, and we can return. And we can return. So it's going to be an easy one, and we are going to return true. If we find out the solution, we will print the solution later. That means we will print the matrix. And in the recursive case, let's see what happens. So in the recursive case, one case could be we are at the end of the row. Okay, so we can say if j equals n, that means we need to shift to the next row. We can say return solve Sudoku, the same matrix, I goes as I plus 1, the column goes as 0, and n remains same. So if you are at this particular point, okay, so if you just cross the boundary, okay, so you want to shift to this particular point. So this is j equals 9, so you say okay, this is I comma j, so this becomes I plus 1, and j becomes 0. So this is what you do. So when this cell makes a call next, you say okay, return whatever is returned by the sub problem, which is starting at this particular cell. Okay, so this is what we do. So I hope this case is clear. And another case could be if the cell is already filled, if it is a pre-filled cell, so we need to skip the pre-filled cell. So how we can find that? If matrix of ij is not 0, okay, that means it is a pre-filled value. We do not need to do anything at that cell, so we just need to make a recursive call on the next cell. And it is possible that the next cell is also pre-filled. Okay, so in that case we will again hit this case, and we will make a recursive call to the next cell. Okay, so otherwise we are on the cell to be filled, and for the cell you don't know what is the right number, so you have to try out all possibilities. So you say for int number equals 1, number less than equals n, number plus plus, and now you need to check whether it is safe to place the number or not by looking at the row, column and the subgrid. So if is safe, I can make a helper method that will check if it is safe to place number at position I comma j, then only I will place that particular number. Okay, so how we are going to place that particular number? We are going to say, let us try to solve this puzzle by placing this number at I comma j and making a recursive call to solve the sub problem. Okay, so this variable solve sub problem will be true if the remaining sub problem can be solved, okay, by placing this number. Otherwise, okay, let us see, if solve sub problem is true, we can say, okay, return true. If it is false, then you can clearly see that this for loop will work. So let me just tell you what we are trying to do. Let's say we are at a particular cell. I say, okay, let us place 1, but we see 1 is already there. I say, okay, let me place, say 2, but let's say 2 is already there. Let me say, okay, let me place 3. Yes, 3 can be placed, so we place 3 here and we make a recursive call on this part. Now the problem arises, maybe by putting 3 we cannot solve this grid. Okay, we cannot form a solution if 3 is present here. Maybe the solution should contain 5 here. What we do, this sub problem will automatically return false. Okay, and what we will do, this loop will work and we will try to place 4 here. Maybe 4 is present here, we will skip it, we will place 5 here, and once we place 5, we make a sub problem, we make a recursive call, and let us say this matrix gets solved and we hit the base case, and in the base case we are going to print the solution. Okay, so whatever the values are there, they will be contained in this matrix and we can just print that matrix. So we can return true if the problem is solved. Okay, if it is not solved, we return false. We try 6, we try 7, we try 8, we try 9. If it is still not solved, we make this cell as 0 and we return false to the previous calls. So this step is going to be called as backtracking. Okay, so we will write the backtracking step now. So if no option works, then what do, you make the current cell as 0, okay, and you tell the previous call that you need to change something and return false here. Okay, so we go back, we again try something on the previous cell, we come to the current cell again. If it doesn't work, we again go back, we may again go back further and so on. Okay, so this goes on like this. Okay, so maybe we come here, and at this point we go back, and maybe it still doesn't work, maybe we go further back, we try to change something here, then we again come here, we update these values, again we may get stuck, we can again come back, we can change here and so on. Okay, so you don't need to dive into how this is working, but if you have an idea, if you can assume that this always works, then it will be easy for you to write code. Okay, so while writing code, you don't need to think how this backtracking is going to work if you are a new or if you are a beginner in solving these type of problems. Once you have written the code, once it works, you can easily verify how this code is working or why it is working. That thing you can do very easily. Okay, so for beginners, I suggest try to break the problem in simpler cases, write the code, and then try to think what is your code doing, why it is working. Okay, so I know it's a bit tricky to explain, it's a bit tricky for the beginners to think, but this is the beauty of recursion and backtracking. You can solve complex problems very easily by writing just simple logic. Okay, and everything is done by this magical function solve sub problem, which is indeed the function that we have written. Okay, so do it for one cell and the rest recursion will do it for you. Okay, so this is the point that you need to keep in mind, how I handle for one cell. Okay, if I cannot fit any of these numbers in my current cell, what I will do, I will say, okay, just make it 0 and return false to the previous cell, and that's it. Okay, so now what we need to do, we need to write this function is safe, and it's going to be a pretty easy function. So let us quickly write the code for this one as well. So let me say bool is safe, I get the matrix, I get the coordinates, I get the number, I get n. So first thing is I need to check whether this number is present in the row or column. So for that I can simply put a loop like this. I can check for row and column. So it's going to be pretty easy. So if I check if the number is either present in the row or in the column, I can say return false. And another thing we can do is we can check for subgrid. Now comes the tricky thing. How do we find out in which subgrid this number is contained? Okay, so let us also learn about this calculation that we are going to do. Okay, so for example, let's say I want to find out for this particular cell. So this is 0 1 2 3 4 5, this is 4 comma 1, and the subgrid for this cell starts at this particular cell. Okay, so if you look carefully, you can easily find out the subgrid. Let us say this is sx and sy, the starting point of subgrid, and this is x comma y. So sx would be nothing but it would be x by 3 into 3. So let me show you. 4 by 3 is 1, into 3 it is going to be 3, and sy is going to be 1 by 3 into 3, that is going to be 0. So this cell is actually 3 comma 0. Okay, and you can verify that this formula is going to work for every cell. Okay, so how this is going to work, I will just give you an idea. So you have a grid of size n, and it is divided into 3 parts. Okay, so we have 3 grids, n by 3, and same holds true for the horizontal and the vertical axis. Okay, so if I want to number these 3 squares from 0, I can give them numbers as 0 1 and 2. Okay, so if I do n by 3, I get the starting, I get the grid number. Okay, so if this is 0 1 2 3 4 5 6 7 8. Okay, so if you just divide them by 3, 6 by 3 is 2, 7 by 3 is 2, 8 by 3 is 2. For them you get 2, for them you get 1, for them you get 0. Okay, and from this 2, you can see the starting point is at 6. So how do you get 6? You multiply it by 3. For this one, you see the starting point is 3. How do you get this? You multiply it by 3. You multiply this by 3. So this gives us the starting points. Okay, so let us try for this particular cell. This is 5 6 7. So this should be the starting point. So this is 7 comma 4. So let us find the starting point for 7 comma 4. So what we do, 7 by 4, 7 by 3 into 3, and 4 by 3 into 3. So 7 by 3 is 6, and 4 by 3 is 1, into 3 is 3. Okay, so you can see this point is actually 6 comma 3. So this formula really works. So once you know the starting point of the subgrid, you can iterate in a square of 3 by 3 from that starting point. Okay, so let us see this logic in the code. So what I'm going to do, I'm going to find out the square root, or I can simply do, I can assume that it's a 3 by 3 subgrid. So sx is going to be I by 3 into 3. Okay, so let us assume that n is 9 in this case, and sy is going to be j by 3 into 3, and for int x equals to sx, x less than sx plus 3, x plus plus. For int y equals sy, y less than sy plus 3, y plus plus. If matrix of xy contains this particular number, then we return false. Otherwise we return true, that this number is not present in the row, column, or in the subgrid. So this is our helper function, and we are done. Let us print the solution. For int I equals 0, I less than 9, I plus plus. For int j equals 0, j less than 9, j plus plus. See out matrix of ij. One thing I need to change, this is the recursive call that is actually solve Sudoku. Okay, so this is solve Sudoku, and we are good to go. So let's build our code and try to run it. So I want to solve Sudoku. So you can see this is the output I'm getting, and let us just verify for few random grids if we have all the numbers from 1 to 9. 1 2 3 4 5 6 7 8 and 9, which seems fine. Do we also have the numbers which are so we should have 5 and 9, so we should not replace the original numbers. We have 5 and 9 here, and let us look at each row. So you look at this row, it contains all the numbers. You look at this row and this column, okay, or you look at this row, it contains all the numbers from 1 to 9. And maybe you also look at this subgrid, it contains all the numbers in the range 1 to 9, and this is true for all the subgrids, and that means our solution seems correct. Okay, so we got a correct solution. So I hope you really understood this logic, and you are now able to implement this Sudoku solver. And this is the backtracking step that you should not miss. And another mistake that people do is they forget to add the return statement. So this is very important, otherwise you will not able to propagate true or false that you are getting from the sub problem to the previous call, and you will get stuck. Okay, so these return statements are actually important here. Okay. So that's it for this particular problem. Thank you. I hope you learned a lot of new concepts.